Hello, good afternoon. Good afternoon to the mathematics class. Class grade XII, permutation and combination. Before starting this, basic principle of counting, a concept for this is very crucial. That's why we need to go through this. So I have determined the objective for the topic today. The objective of today's topic is to get the concept of number of ways of doing something in mathematics or in daily life activities. We do something in different ways. There are so many options of doing something. So it can be achieved by basic principle of counting. So today's objective I have chosen is to get the concept of number of ways of doing something and apply it to the practical problems. Practical problems in the sense it may be used to find the ways of forming 2-digit number, 3-digit number, or go and come purposes, yes, and for permutation and combination also. Okay, let's start with an example. Suppose there are 2 entrances and 3 exits in a hall. Let's find out the total ways in which a person can enter and get out the hall. Yes? So in a hall, 2 entrance gate and 3 exit gates. So I have written the entrance gate as E1 and E2, capital letters, and the exits are E1, E2, E3 with small letters. So what are the possible ways? Let's do something. Let's expand. The possible ways are that man, okay, let's make a man here. That man may enter this door and exit this door. So E1, isn't it? So another way is that man may enter E1 and exit E2. So E1, E2. Similarly, it goes on E2, E1. So going inside, he can use E2 door, and outside he can use E1 door, and so on, isn't it? So how many possible ways there are? Counting it is 6. There are 6 possible ways. Let's generalize this concept. He can enter the hall in any one of the 2 ways, isn't it? Any one of the 2 ways or 2 doors. So N1 equal to 2, let's take. And he can exit the hall in any one of the 3 ways, that is N2 equal to 3. So then total ways he can enter and exit the hall equal to, we have seen here 6, which is 2 times 3, or we can say N1 times N2. The total way is equal to 6, isn't it? Now go to the statement to formalize this or to generalize this concept. If one task can be independently done in N1 ways, so here entering the hall is one task. Second task can be done in N2 ways independently. Here may be another hall. Okay. Third task can be done independently in N3 ways, and so on. There are so many activities may happen all together at a time. Then total number of ways in which all of the tasks can be done in the stated order, means entering and exiting in that order, in the same order, is N1 into N2 into N3. This is known as basic principle of counting. And let's take some example, very interesting example to apply this concept. Example 1. There are, suppose, 5 doors in a hostel. in how many ways can a person get in and get out of the hall so that we can say without using the same door twice. Let's take an example like this. So clearly there is a hall, yeah. So how many ways he can get in? How many doors there? 1, 2, 3, 4, 5 doors. And that person may enter this D1, D2, D3, D4, D5. So he can enter D1 door and may exit in D5, let's me, right? D5 ways. This may be the way. But he cannot use D1, D1. Means entering from D1 and exiting from D1 is not allowed. Yes. So this is not allowed. So we are asked to find the ways D1, D3 like this. D2, D3, D5, D2 like that ways. How many ways altogether? So let's make the use of the concept discussed earlier. So there are how many ways to get in? There are 5 ways, 5 independent ways to get inside. So N1 equal to 5, yeah. But there are 5 minus 1. Why? Because that person cannot use the same door twice, which was used earlier while entering. That's why this is 4 ways to get outside. Therefore, N2 equal to 4. So total ways by basic principle of counting, we can write N1 into N2, yeah? Ways equal to, so 5 times 4, which is the formula N equal to N1 into N2. There are 20 ways in this condition to get in and to get out. Let's take another example. Very interesting one. Example 2. Making 3-digit number. Let me drop this. How many 3 digits number can you form from the digits 1, 2, 3, 4, 5 using only once? So we are asked to form the ways of 3-digit number without repeating the digits. So 3-digit means, as we know, 3-digit means, let's go to the place value, ones, tens, hundreds. Yeah. So we are making like this, 423. This is a 3-digit number using by the digits only once. So this is not allowed. 424. This is not allowed because 4 is coming twice. 444 not allowed. 4 is coming thrice. Like these are allowed. Okay, how many ways? 421. Okay. 523. Okay. So this type of number, how many we can develop from these digits, isn't it? Now, so to do this, we use the basic principle of counting concept. So ones, tens, let's go through place value table, hundreds. Why we are taking this format? You know, 3-digit number is, the place value is ones, tens and hundreds. Let's choose any one digit for ones place, because out of these 5 digits, 5 choices for the unit place, you can choose any one of the digits. So there are 5 choices. You are free to to choose the digits here. That's why this is 5 choice, 5 ways. The ones place digit can be chosen in 5 ways. Similarly, tens place digit can be chosen in, because any one of the digit is here at one time. So there are 4 options, because we cannot repeat the digits. That's why, so 1 is already packed here. Let's think in this way. 5 minus 1 equal to 4 choice, or 4 ways. We can choose the tens place digit in 4 ways. Similarly, as 2 of the digits are already used and we cannot repeat the digits, so there are how many options for hundreds place? This is again 1 less, 4 minus 1 equal to 3 choices. So we can write language like this way. Ones place digit can be chosen in 5 ways. So n1 equal to 5. I'm not writing the language in detail, you have to write. So similarly, tens place digit can be chosen in how many ways? 4 ways, because we cannot repeat. So hundreds place digit can be written in or chosen in 3 ways. So total ways of forming 3-digit number like these are, total ways equal to n1 into n2 into n3, so which is 5 into 4 into 3, which is 60. So we can make 60 such 3-digit numbers without repeating the digits, using these digits only once. Let's take another example. Okay, example 3. Drop this again. How many? Okay, 3 digits number can be made out of digits 1, 2, 3, 4, 5, 6, 7, which are odd numbers. So this problem is similar to the previous one, only we are choosing the odd numbers, or we are choosing odd digits in the unit place without repeating. Okay, here also without repeating. Without repeating the digits. So what this question is asking, 1, 2, 3, like this number, 1, 5, 7. Odd number, 3-digit odd number. 4, 2, 7, it is also okay. So even numbers are not allowed here. 3, 2, 1, okay. This type of number, how many you can make, you can form. So let's draw a table again. For 3-digit, we need to make similar place value table. Ones, tens, hundreds place value. Okay, ones place digit. So we are given 1, 2, 3, 4, 5, 6 and 7. Out of these 7 digits, there are how many odd numbers are there? How many? 1, 3, 5, 7. If we place these any one of these 4 odd numbers in the unit place, then we can make odd 3-digit odd number, isn't it? So how many choices do we have to put in ones place? 4 choice, isn't it? 1, 2, 3, 4. Any one out of these 4 can be placed here. So you need to think about the number of choices to put in. Okay, 4 choices. Now what about tens place? The tens place digit, while entering here, you have to think that the digit should not be repeated. Suppose 7 is placed here in ones place, automatically your choice one choice is decreased. That's why. So altogether we have how many? 1, 2, 3, 4, 5, 6, 7. N equal to 7. So you need to subtract 1 because one digit has been already used here and cannot be used same here again. That's why 7 minus 1 equal to 6 choices. Okay. So again 2 digits are already used in ones place and tens place. That's why in hundreds place we have the choices left is 6 minus 1 again. So which is 5 choice, 5 ways. So N1 number of ways of choosing ones place is 4. N2 number of ways of choosing tens place digit is 6, and that of hundreds place digit is 5. So total ways or required 3-digit numbers are 4 into 6 into 5, which is 4 times 6, 24, 5 is 120. Yes? Now go to 4th example. Okay, let me drop this. Example 4. How many? Okay, let's say 4-digit number. 4 digits number. Can you make out of 0, 1, 2, 3, 4 and 5 without repetition? Without repetition. Okay, P-A-T-I. Without repeating the digits. Okay, how many 4 digits number can you make out of 0, 1, 2, 3, 4 and 5? So here 0 coming, isn't it? So we need to take care about 0. So 4-digit number. As usual, let's write the place value table. Ones, tens, hundreds and thousands. So this question wants what type of number? 1, 0, 2, 3. Okay. No odd, no even. Any number you can make. 2, 5, 7, 0. Okay. 4-digit number. It's okay. Oh, not 7. Sorry. 4, 0. Okay. There is no 7. You need to use out of these digits. So what about 0, 1, 2, 3? Is it okay? Maybe 0, 0 also may come here. So this is not okay. So 0 in the thousands place is not allowed. Why? Because it doesn't have any value. So it is just a 3-digit number, no more 4-digit number. That's why we need to take care about this. So our restriction is in thousands place. We need to remember that. Our restriction to put 0 is in thousands place. So how many choices do we have for thousands place? 0, 1, 2, 3, 4, and 5 are the digits. Yeah. So altogether there are how many? 6 digits. Out of these 6 digits, we are making 4-digit numbers. So how many 4-digit numbers can be made? We are doing this. So don't go through ones place because our restriction is in thousands place. So focus on thousands place. How many ways in the thousands place digit can be chosen? Can we put 0? No. So how many ways? 1, 2, 3, 4, 5. Remaining all can be put in thousands place. Isn't it? Like this, like this. Okay. Or 4, 5, 2, 3. That's also okay. So, but 0, 1, 2, 3, 0, 4, 5, 6. No, okay. So, we need to put how many choices? Sorry, I'm sorry. 5 ways. Why? Except 0, we can put any one of the digits in thousands place. Now you can move from here to here or here to here. No worry. Okay. Hundreds place. How many choices do we have in 100 place? Student. Because one digit is already used here, you cannot use that again in the other place. That's why we have only left 5 choices, isn't it? 6 minus 1 equal to 5 choice. You need to understand this. Now, accordingly, for tens place, 2 digits are already used. That's why 5 minus 1 again. So, 4 choices and 4 minus 1 equal to 3 choices. Now, do multiply these choices to get the total number of ways of required answer. Okay. Therefore, total number of way equal to n1 into n2 into n3 into n4. Let's n1 is this, n2 is this, whatever. Okay. So 5 into 5 into 4 into 3, which is 24, 25, 4 is 100, 300. 300 such 4-digit numbers can be made. Yes, 300 such 4 digits number can be made. If you practice, it may take hours long, but by the concept or by the technique, it may come in few seconds if you know this. Yes. Let's take another example. 5. How many numbers between this type, yeah? Between 3,000 to 5,000 can be made using 1, 2, 3, 4, 5, 6, 7, let's say. Only once. Let's do this. Between 3,000 to 5,000. Yes. 3,000 to 5,000. So focus your mind on thousands place again, because we have restriction here in thousands place. We can make like this way: 4, 2, 3, 1. Okay, fine. 3, 1, 2, 4. Fine. Okay. 4, 1, 2, 7, fine. 3, 2, 7, 1, fine. This type. So what we see is always we are getting 4 or 3 in the thousands place. Why? Because we need the number greater than 3000, isn't it? Greater than 3000 and less than 5000. So we cannot put 5 in the thousands place. If we do so, this is out of the demand of the question, isn't it? So we can put only 3 or 4 in the thousands place. So how many choice do we have? Just 2. So ones, tens, hundreds, thousands. So let's calculate the choice and then multiply them to get the answer, okay? Thousands place. How many choice do we have for thousands place? We cannot put other digit, except 3 or 4 in the thousands place. That's why, how many choices do we have? 2 ways. Ways or choices, whatever you write, okay? So thousands plus 2 ways. Now remaining place can be filled up by this way to this way or this way to this way, or left to right or right to left, whatever. So hundreds place, how many choice for hundreds place? So any one of the digits, available digits, is used here already. That's why, how many choices does the 100 place have? We can choose 100 place in, altogether we have 7 digits. Yeah, and any one of the digits, either 3 or 4 in this place value is already used. That's why we need to subtract 1, which is 6. And similarly, as usual, okay, 6 minus 1, because 2 places are already been filled up with the 2 digits. That's why 5 choices for tens place, and 5 minus 1 equal to 4 choices. So n1, n2, n3, n4. So total wage. So one thing, you can write this order 6, 5, 4 or 6, 5, 4. Anyway, after fixing this thousands place, no worry, okay? So n total ways of forming the number under this in this range is n1 into n2 into n3 into n4, so which is 2 into 6 into 5 into 4, 2 6 the 12, 5 the 60, 4 the 240. 240 such numbers can be formed using the condition given. Okay, the last one example I'm giving you is about the using of roads. Okay, using of roads. Example 6. Suppose there are 5 main roads between city X and Y, and 4 main roads between city Y and Z. Question is this: in how many ways can a person drive from X to Z and return Z to X by using X without using, let me write, without using same road twice. same road twice. Okay, so here let's figure it out. CTX, okay, CTY, CTZ. So how many roads, link roads between CTX and Y have here? 4, 5 here. 5 roads. Let's make R1, R2, R3, R4, R5. And how many link roads between here to here, Y to Z? 4, isn't it? So R1, R2, R3, R4. So this person is driving from X to Z via Y and Z to X city via Y again. But the condition is that he cannot use the same road twice without using the same road twice. So it means he may use, I am giving you one example, R1 while going, and while returning maybe R2 R1. That is fine. R2 R1. So while going and while returning, he cannot use the same road twice. Means R1 R1, implies R1 R1 is not allowed. So R1 R2, R1 R2 is small right. Okay, here small writing. So let me write here is small while returning R2 R1, and while returning, let's see, R3 R1. This may be. So how many such possible ways there without repeating R1 R1? No. R1 small R1 returning back, R1 small capital R1. No, that's not fine. So without those options, how many options does that person have? So we are going to calculate this. So in shortcut, it can be done in this way. He or she can drive from X to Z in how many ways? What are the options there? Multiply. Because while driving from X to Z, he can use any one road, any of the roads. So N1 into N2 by basic principle of counting. So 5 times 4 equal to 20. So going from X to Z is in how many ways? 20 ways. So this is N1 say. And he can drive from, while returning, from Z to X in. Now, as the condition of the question, he cannot use the same road twice. That's why subtract 1 in the respective choices. That's why 5 minus 1 multiplied by 4 minus 1. So which is, this is 4 and this is 3, 12 equal to N2 say. So total way by basic principle of counting, going from X to Z and returning from Z to X is total ways equal to N1 into N2 by basic principle of counting, which is 20 times 12, which is 240. Thank you. I hope this class is very fruitful for you today, and in the coming days this concept will be used for permutation and combination in many steps. So hope you can get this objective also. Thank you very much. Thank you, class.